Okay. Hi, everyone. Thanks for joining us today. My name is Jayden Aung. I'm a regional cloud security architect with Checkpoint. I'm based in Singapore. I focus on ASEAN region, including Singapore. So today, I'll be talking about one of the most exciting topics around cloud security and DevSecOps, the serverless security. And I also be talking about how Checkpoint can help you secure your cloud native applications while maintaining agility on the cloud. But first, I'd like to touch on the basics. What is a serverless application? How does it benefit you? And how does moving towards serverless impact your cloud security strategy or your DevOps culture? Because we've been seeing many organizations moving their workloads to public clouds for a variety of reasons. Many organizations are also moving away from traditional monolithic kind of application architectures and further towards service-oriented or microservices application architectures. Those architectures revolve around containers and serverless platforms. Today, we'll be talking about serverless. So let's just start with what is serverless. Serverless compute platforms or serverless applications are mostly deployed on public clouds like AWS or Azure. Actually, there are many definitions around what serverless is, but the way I see it, serverless is all about shifting your operational burden or responsibilities to cloud service providers. Because with serverless, operational responsibilities of the underlying infrastructure are managed by cloud service providers, so you don't have to worry about them. You don't also have to worry about managing virtual machines, patching operating systems, scaling, high availability, and other operational overheads, and so on. That effectively increases your development team agility and innovation because you now can map the engineering resources to what really matters to you the most, the innovation. You just need to provide the business logic, and the rest is taken care of by the cloud service providers, which is fantastic. That fundamentally is the kind of driver behind the serverless hype that we are seeing right now. With that in mind, we can basically think of serverless as an operational continuum. So let me give you an example based on AWS. So if you take a look at this, on the far left side, you've got completely non-serverless services. So if you're using one of those services, for example, EC2 instances, you'll be responsible for operational tasks such as managing the maintenance of the underlying compute resources, operating systems, patching, network configurations, high availability, and so on. Because that is IaaS, infrastructure as a service. So on the far right side, though, you've got services such as AWS Lambda, where everything except for your business logic is taken care of by the cloud service providers. By business logic, I mean the application code. So in the middle there's a number of different options where you can offload more and more operational tasks to cloud service providers as you move to the right. So it's not necessarily all or nothing. You can absolutely take steps towards becoming more serverless in your architecture, which also resonates with operational excellence best practices. So the goal is to have the cloud service providers take care of almost everything in the infrastructure so that your team can now focus on what is really important to you or your customers, right? So here are some of the key attributes of serverless applications that I'd like to share. Firstly, no infrastructure provisioning is required because cloud providers are obviously taking care of it 100%. Basically, the operation tasks around compute, storage, and network are managed and maintained by cloud service providers. So these include things like operating system patching, updates, and so on. And serverless is a very cost-effective model because you only pay for what you use. So in the case of Lambda, which is a serverless compute platform, it is pay-per-invocation pricing. So you only pay each time a function is invoked. Now you can stop paying for the back-end infrastructure when you're not using it. So that is not like hosting containers. So you don't need to pay for the underlying runtime environments when they're not being used. And the serverless platforms are highly available and redundant. The backend infrastructure is built in a highly available fashion, which is completely transparent to us. So again, that is also taken care of by cloud service providers. And lastly, the serverless platforms can automatically scale based on the requirements, based on the workload demands, and so on. So again, it is also taken care of by the cloud service providers, so you don't have to worry about them. So these are some of the benefits, that are appreciated by many organizations and DevOps teams, mostly because they can now focus on innovation only and not care about what happens to the infrastructure. So what I've shared with you so far are some of the cool things about migrating towards serverless platforms. But what about security? Now that you're on serverless and your cloud service provider is taking care of the infrastructure, does it mean you are 100% secure? Absolutely not. Serverless functions are different. In the case of Lambda functions, the functions can be invoked from a number of different sources. They can be invoked by an external API call. They can be invoked for an event or even by another function. Technically, they can even be invoked by a simple SMS message. That changes everything. Okay, so here are some of the security challenges that we are seeing with serverless applications. The first thing is your application code. When we talk about your application code, you need to focus on the dependencies that you're using. You need to make sure that there's no vulnerability in the dependencies that you're using, because if you have, the attackers can basically leverage on the vulnerabilities and compromise the functions, compromise other cloud services. And also you need to make sure that there's no embedded credentials. So if you're using any credentials such as password, API keys, or secrets, they need to be secured. The second thing is the cloud infrastructure. As I mentioned earlier, your serverless functions can be invoked from a number of different sources. So we have to correctly define the resources, the events, and the permission. We have to make sure that there's no excessive permission attached to the role that the function is using. Okay? And lastly, DevOps challenges. How do we integrate security checks into CICD pipelines? And how do we automate them, right? So we don't want DevOps process to stop for a security check, okay? So we have to make sure that the security checks are automated. And lastly, we have to infuse the compliance and governance into the CI/CD pipeline. So this is OWASP Serverless Top 10. So OWASP is basically an organization that focuses on application security. They do security research a lot, and from time to time, they release a list of serious applications and serverless security issues that we should pay attention to. They are known as OWASP Serverless Top 10, and what you're seeing here is the list. So here we can see things like cross-site scripting, sensitive data exposure, etc., etc. But one thing to take note is that the dependencies with known vulnerabilities is one of the most serious issues. Okay, what is wrong with this code? So this is a sample function code that I pulled from OWASP Top 10 website. So in this example, we can notice that the API key and secret key are embedded in the source code. Therefore, they pose a risk of sensitive data exposures. So that is if the function is compromised. In this scenario, the function uses the API key to, take actions and interact with other AWS services. So if the function is compromised, the attackers can use the same API keys to gain access to other cloud services, right? So if the function has the permission to update a database, for example, the attacker could leverage on the same permission and manipulate the database. So this is a great example of sensitive data exposure vulnerability. This makes the OWASP top 10 list. Therefore, we should have a means to run assessment on the source code for this kind of vulnerability. And we should be able to detect and address this kind of issue at the development stage or build stage, or should I say, as early in the CICD pipeline as possible. So how about this one? So in this example, the function is vulnerable to command injection attacks. So it will expose this vulnerability in case a downloaded file does not end with the required file extension, for example, .jpg. So to exploit that, an attacker can use the application legitimately, but uploads two files. So one of them contains a command injection syntax in its name, and you can basically exploit this vulnerability very easily. So this is an example of a command injection vulnerability, and that is something we should take very seriously. So now, let's talk about what Checkpoint as a security vendor offers to help you secure cloud-native applications. We've been known for our award-winning security solutions such as Next-Gen Firewall, and Checkpoint also has a suite of cloud security products called CloudGuard, and it is a product family. CloudGuard consists of different cloud security products or modules. So I give you a very high-level overview of what CloudGuard is before I dive into the serverless security. The first one is private and public cloud network security. This is basically our Next-Gen Firewall in a virtualized form. The image is optimized for multi-cloud environments. So you have a security gateway sitting in front of your application servers on the cloud, inspecting east-west and north-south traffic. You can have features such as IPS IDS, SSL decryption, and sandboxing, and so on. And you can have them all on the cloud. Okay, and we have added capabilities such as automation, automatic provisioning, and API communication with cloud service providers. So it can monitor changes on the cloud and automatically discover and secure newly created applications. So it can basically work with cloud native applications. So moving to the right side is a cloud security posture management, or CSPM. So CSPM focuses on cloud control plane. It allows you to gain visibility into your cloud assets, network configurations, and the metadata around your cloud workloads. And it also acts like a virtual auditor, which can run continuous compliance assessments and inform you of misconfigurations and compliance violations based on industry standard frameworks such as PCI DSS. So also, it allows you to respond to incidents and automatically address misconfigurations using auto remediation features. Then let's move on to the lower right side. We got CloudGuard workload protection, which is the focus of today's session. Right, so it focuses on cloud-native application security. We're talking about containers and serverless. So the serverless bit is the focus of today's session. And CloudGuard workload protection can access your workloads for misconfigurations, vulnerabilities, and enable runtime protection on the workload as well, which basically is acting like a firewall. Then on the lower left side of the pie, we've got web application and API protection. We also call it AppSec. Right, so this is a machine learning based Next-Gen Firewall security tool for APIs. It basically protects your web applications and cloud workloads from API abuses, bot attacks, and malicious API calls. You can even consider this as a Next-Gen web application firewall, only that this is not signature based, it's purely machine learning based. Lastly, we've got cloud intelligence and threat hunting. So it is a product or module within CloudGuard, and it focuses on security incidents on the cloud. It basically allows you to monitor user activities and network activities and alerts you upon detection of malicious behavior or malicious network activities. So based on the correlated events, you can then run threat hunting operations and even further analysis. So all of our cloud security products are all about advanced prevention and heavily automation driven. So they can easily be integrated into your CI/CD pipelines. CloudGuard Workload Protection aims to secure cloud native applications such as containerized applications and serverless applications. In this section, I will touch on how CloudGuard can protect serverless applications on public clouds. Before I talk about serverless security solution provided by Checkpoint, I'd like to touch on Threat Cloud. So Threat Cloud is Checkpoint's very own threat intelligence database, and it is also an AI. So behind the scene, it has 64 different engines that can detect both known and unknown threats. So it's been emulating millions of files every day, and it's been stopping thousands of zero-day threats on a daily basis. And I'm telling you this because Threat Cloud is part of our cloud security solutions because it is feeding us threat intelligence, right? It is influencing the security decisions that cloud security solutions make on a daily basis. Okay, now let's talk about CloudGuard Workload Protection. So CloudGuard Workload Protection is what Checkpoint has to offer for securing cloud-native applications such as containerized and serverless applications. Of course, today we'll be focusing more on serverless. Okay, we're going to talk about how we can integrate our solution into your CI/CD pipeline, how we can be part of your DevOps culture and processes. Okay, how we can automate the security within the CI/CD pipeline. CloudGuard for serverless application is a code-centric security tool which can be integrated into your CI/CD pipelines. It focuses on securing serverless functions such as Lambda and Azure functions. It allows you to harden your function configuration and code. It allows you to gain visibility into threats against your functions and so on. You can also turn on the protection mode if you want to, protect your functions from certain attacks. And deep code flow analysis will allow you to monitor and profile your application's behavior and activities. When securing serverless functions, we need to look into different areas of serverless platforms, and we also need to look into how we can perform risk mitigating activities throughout the CI/CD pipeline. With serverless protection enabled, CloudGuard can continuously scan your serverless functions for vulnerabilities and risk, and you can also apply runtime protection to your functions when they're invoked. So we aim to enable these security features and integrate security capabilities into your CI/CD pipeline so that your serverless applications are continuously secure at different stages of the CI/CD pipeline and also runtime. Throughout the CI/CD pipeline, CloudGuard performs both posture management of the serverless functions and workload protection. So with the posture management, CloudGuard enables you to check and scan your configuration of the function. It can scan the code, the application code for vulnerabilities, dependency vulnerabilities and embedded credentials. And lastly, you can also define and enforce security policies on the function. So that is something that we can do at the pre-build or build stage. At the runtime, what we can do is you can turn on the workload protection. It is sort of like an advanced firewall for the serverless applications. So it can detect and stop applications layer attacks such as command injection or cross-site scripting and so on. So with the deep code flow analysis, it can automatically and accurately profile and enforce functions and application behavior. right? And again, you can set and define and enforce code level zero trust boundaries across the functions. And we have built-in integrations for alerting and forensics. We can be integrated into a number of CI/CD pipelines and CI/CD tools as well. Okay, so this is basically a screenshot that I got from the CloudGuard workload protection console. As you can see, we have a function here being analyzed and protected by CloudGuard workload protection. So you can see that we have a configuration scanning enabled. With this enable, you can basically assess the functions and configurations, and it can flag out if there's any misconfiguration around the Lambda functions. And we can see that there's a vulnerability scanning enable, so that you can scan the source code and dependencies for vulnerabilities, and it can flag out as well if it finds any vulnerabilities. And the IAM hardness enable, with this, it'll be able to tell you if your function is using very excessive permission, and it can even suggest, an IAM policy based on least privilege principle. And workload protection is also enabled, so that it can actively fend off attacks that are coming towards the functions. So that is for runtime, right? So when the application is at runtime, you might want to have the workload firewall enabled so that it can block off certain attacks. And you can see that the behavior prevention is also enabled, which means that the CloudGuard is actively analyzing and profiling the Lambda function, for activities, for the behavior, and so it can flag out if there's any anomalies and if there's any malicious activities. You can see I have 6 findings and 2 alerts, which you can check out in a separate console. And we can also see that we have a posture rating of 25%, which means this function is not doing well in terms of compliance and security. So this is just a screenshot from my own GitHub repository. It is a tutorial that I made about integrating CloudGuard with AWS code pipeline. So in this scenario, we'll be part of the CI/CD pipeline doing the security checks. Okay, so you can also use our static code analysis tool during the development stage, to scan the code offline for vulnerabilities. But we can also be part of the CI/CD pipeline in an automated manner. So in this scenario, we have developers here checking out the code via the code commit, which will then cause the entire pipeline change to happen. And then, AWS code build will kick in and then start building the code. So this is where we come in also. What exactly we'll be doing will be define and build spectral YAML, right? So what we'll be doing is basically scan the code for vulnerabilities, things like embedded credentials, and making sure that there's no misconfigurations or security issues. So if there's no security issue, then we'll push it to code deploy, which will then deploy or publish the code via the CloudFormation, right? So if there are any issues, security issues at the build stage, you have the option to stop the entire pipeline, stopping the functions from being published. So if there's no issue, of course, the functions will be published, as part of the CI/CD pipeline. So even when the code is published as a function, you still have the option to secure the function by turning on the workload firewall. So when the workload firewall is turned on, it will proactively fend off application layer attacks such as cross-site scripting or API attacks and so on, right? So that is how we can continuously secure your serverless applications throughout the CI/CD pipeline. And even when it is at runtime, we can still proactively secure your function. Okay, this is just another screenshot from CloudGuard Workload Protection. This is just an alert generated by an event where an attack was being blocked off by CloudGuard Workload Firewall. That is because active workload protection is enabled at runtime. So the attack could have been successful without the active protection enabled. So now it was blocked up because it is enabled. Now you can see the details of the attack in this alert, and you can send this information to SIEM or any other monitoring tool as well. So putting sec in DevOps or DevSecOps is all about infusing risk mitigating activities throughout CICD pipelines. It is all about a holistic, secure by design approach to code and to delivery, and it all involves people, process, and technology or tools. So what I just presented so far in this session is how Checkpoint CloudGuard can play a role in helping you achieve that and securing your cloud native applications using a technology powered by the best security vendor with the best threat intelligence and the best automation capabilities that can work with your DevOps processes. Okay, so just to wrap up and summarize the takeaways for today's session, basically CloudGuard Native is a unified platform for cloud infrastructure, containers, and serverless applications. Of course, today we focused on serverless application security and how we can achieve it using automations and being able to integrate with CI/CD pipeline. We have the posture management capability where you can gain visibility into the compliance status of your cloud infrastructure, and being able to enforce governance into your cloud environment as well, and being able to scan your code for vulnerabilities, being able to scan your dependencies for any vulnerabilities as well, and also runtime protection. That is, also known as workload firewall. Once you enable it, the CloudGuard will be able to fend off attacks continuously and actively. So it's not only monitoring and scanning of the security issues, but being able to actively protect your serverless application as well. And of course, you gain visibility into the serverless functions and the kind of API calls that are being made and so on. You can run analytics as well. And we have integration with many CI/CD tools. In today's session, I just show you one. Okay, the integration between CloudGuard and AWS code pipeline. Of course, you can integrate CloudGuard with almost any CI/CD tool like Jenkins, Azure DevOps, and so on and so forth. And lastly, the major takeaway is being able to continuously protect the serverless applications, be it at the build stage, be it at the runtime. You will be able to protect your serverless applications, and also we can do so continuously throughout the CI/CD pipeline. Okay, with this, I'd like to conclude my session. I hope today's session has been informative to you. If you want to find out more about Checkpoint's cloud native application security solutions, you can check out our website or our official GitHub repository, or even my personal GitHub repository. So we have published many tutorials and sample codes on how to integrate CloudGuard with many CI/CD tools. So I'll be happy to answer any of your questions today in the chat box. Otherwise, I'd like to thank you for your time and have a great day ahead.